Officer at the Institute of Quantitative Social Science at the Harvard University. She has more than 10 years of experience leading the Dataverse project and more than 15 years of experience building data management and analysis systems in academia and biotechnology companies. She is part of numerous committees and working groups focused on data sharing, research data management, data citation, and data standards. She is co-PI of Dataverse project with IQSS Director Gary King and supervises the Consilience project for text analysis, the data science services, and data curation team at IQSS. She collaborates with a wide range. Sorry, just something wrong happened with my. Oh, but
it's okay.
It's okay. I finish right here.
Many collaboration.
Okay. So, thank you.
Thank you. Thanks for the invitation. Thanks, Pedro. Thanks, the Forum for having me here. I'm really happy to have this talk. I have to say that forgive me for the long title. I think Pedro suggested it, and somehow it ended up being Research Data Management at Harvard, Data Sharing, and the Dataverse project. So I like to start. Let me see this one. Okay. I usually like to start my talks emphasizing the value of data. We are here because we have recognized that data are important and are very valuable for research. The economists realized that also about a year ago and added this article that was titled, "The World's Most Valuable Resource is No Longer Oil, but Data." And of course, as you know, the tech giants have already, they learned that in the last decade, and much of their success is because of how much they value data and how much data they gather. So in universities and in research organizations, academic institutions, we need to think of the same way that data are very valuable. They are an asset to the universities, so that we need to take care of them, handle them with care. And how do we do that? So it's an effort that it takes more than just one group. It's a collaborative effort that includes usually the library, the information sciences in an academic institution, the researchers and all the bodies that support the research, like vice provost for research and sponsor research and also the infrastructures, the information technology, research computing, and that comes along with security, and just data centers, storage, etc. So we need to put all those things together. Not each one of that can support data and the whole data life cycle alone. But when we work together, that's when we're more effective. So most of you here know what research data management is. That's why you're here. But let me remind you of the aims, right? So first, this comes actually from the Digital Curation Center, which we saw a little video from Sarah, sent by Sarah Jones, right? So a few years ago, they were one of the pioneers creating research data management materials, and they wrote this paper to make a case for research data management. And they said that research data management concerns the organization of data from its entry to the research cycle through the dissemination and archiving of valuable results. It aims to ensure reliable verification of results and permits new and innovation research built on existing information. So those aims are important to be reminded, because it's not just we just want to do data management to do data management, right? We want the results of that, and the results are valuable data that can be reused. Reused not only by the person who created them, but by others, whether they're the students or the collaborators or others in the other side of the world, right? And to do that, we need to manage it well so they can be reused. And we can use also that data to verify existing results, scientific claims, publications, and that has shown to be important even more in the last years when we see publications that say that many of the published work doesn't replicate easily, right? You could take the data and the code and everything and try to reproduce it, and often you don't get the same results. And it's not because anybody is doing necessarily anything fraudulent or because of bad intentions, but because science is difficult, and there are many ways of analyzing, there are many parameters, many factors that could influence the results that you have in a publication. So having data that can be well understood, it can be reused easily, will help verify those results. And that's the core of science, right? The core of knowledge, to be able to verify what you claim or your results. So the other important part to emphasize is that research data management. It covers a very large range of research domains, but also of data types and methodologies even, and so you cannot just build, even though there might be some common parts of data management, you cannot build something that works for all completely. You cannot just provide training that it's exactly the same for every field, and so. But you can find the common areas that are conceptually applied to all the fields, and then go deep into where the differences are. So, for example, you might do some different. Have different tools and different advice and guidelines for qualitative data versus quantitative data, but also how that qualitative data is used for qualitative methodologies or quantitative methodologies, right? It's also different when you think about small to medium data compared to very large data sets of terabytes and petabytes, and you have to plan for that larger storage. You might not be able to download it and have it in your laptop and work on it on your laptop, so you'll provide other tools for computation. And we see more unstructured data, right? There is a structured data, like maybe in a table, in a relational database or so, but there is a lot of structured data that could come from social media, from imaging, from sensors, and so that you need to work on in a different way and apply different methods. And of course, there is more streaming data also, so that those have their challenges too. So at Harvard, we've been working in the last now about couple years, coordinating how we support research data management. Even though that we've realized that long ago that we needed to do that, it is a challenge. It's almost like a small country, like a microcosm of a country, because we have 10 schools and each one is very independent, is very decentralized in general. So we're trying to centralize some of the infrastructure to take advantage and make sure that we're not duplicating efforts when we provide support for research data management. So this site is still under development, but we started to work with the medical school, the School of Public Health, the Kennedy School of Government, the law school, the arts and sciences, and all these different groups, and with IT, research computing, the library, to put together what Harvard researchers, what kind of resources they have for research data management. The thing, that I want to emphasize with that is not that to know how we support research data management, but what it is important is that we focus very much on how, the researchers are the audience of this website. So when we provide training, sometimes what we call the curse of knowledge. We try to think about it, since we know more about that subject, we don't think about it how, from the perspective of another that doesn't know what is that they would need to learn, right? And what they will be interested in. They might not be interested in everything that somebody that focus all the time in research data management want to know. They might not care about all those things, but they'll care about what is important to them, how it can be easy and integrated with my research life cycle, and how I can just make use of the tools without disturbing what what I do for my research and be able to focus on my research, right? So we're trying to provide these resources in a way that we test them with professors there, with researchers, with postdocs, and so to make sure that it is useful to them. And that's why we're building these use cases for qualitative research, quantitative research, sensitive data, and big streaming data to just illustrate how data management for these type of cases that sometimes could be across different disciplines. So we didn't want to focus on just one discipline specifically, but more on the type of data and the type of research that you would do and how, what you would need to know and what are the best practices in every case. So for the way we've structured that is having for every phase of this data life cycle, from planning to data collection to storage and analysis, and then finally the data sharing and archiving. So for each one of these, we have a set of questions that a researcher would want an answer, a quick answer to it, right? How do I do that? What does this mean to me? And so, I don't need to go through every question, but just an illustration of how to approach how to provide this support and documentation and training materials for research data management, again, in a way that it is useful and if you can, proven useful, right, by testing for researchers. So for this phase, when you're planning your data management, the key points are as this group mostly know, right, that is the definition or creation of a data management plan. Data management plans help you just think about, even if they might change over time, but before you start a project, it helps you think about what you're going to do with your data throughout the project, where you're going to store it, what tools are you going to need, what are the formats and the documentation and the metadata that you'll provide associated with your data, and at the end of the project, where is it going to live in a way that it can be accessible by others, right? As you know, also the DMP is required by many of the funding agencies or funding organizations, Horizon 2020, for example, but also then if you work with any collaborations with the US or other groups there, and foundations like the Gates Foundations, the Sloan Foundation, many others that also require a DMP, and all the federal agencies in the US too. I emphasize again that the DMP is a living document, so it's not you don't necessarily create it once and then we don't touch it again. One of the useful things that we're trying to do at Harvard with DMPs is that as they get created in the beginning of a project, we want to make sure that they are tracked and the IT groups know about it, the library knows about it, all the sponsored research office knows about it, so that, they know what to expect, right? What is that they will need to be prepared for this project and to be able to support the data that comes with that project. And as the project progresses, it might change, but you keep updating it and informing all the groups that will provide the infrastructure and the support for your data. So the DMP tool helps you to define, to understand what are the requirements from different organizations for DMPs and what templates they provide. How many of you know about the DMP tool here? How many of you? And you know that last year there was a launch of a new version that it's now international, that it merged the DMP online, that the UK and the data, the Digital Curation Center, the DCC, was supporting, plus it merged a tool from Australia, from I think New Zealand, from different locations in the world that had provided this type of tool to be able to show here the templates, the requirements, right, for all the DMPs, but now they combine it all into one DMP tool in dmptool.org. So But besides the fact that there are some organizations that require data management plans, what we tell our researchers is that they're useful even when they are not required, right? If we could even if it's just a checklist of things that you need to think about in the beginning of your project as it refers to your data, that's important. And the Nature editorial in 2019, in the beginning of this year, had this article about exactly this, that everybody needs a data management plan. So what they said is that first, rigorously collected, well-preserved data sets, including meaningful descriptors or metadata, will help the data owners to reach solid, meaningful results. Okay? And second, they will help future investigators to make sense of and reuse data, thereby enhancing utility and reproducibility. So again, the first points, the points of research data management, right? Utility and reproducibility. Preserving comprehensive data, ideally for many years, also reduces the risk of duplicating science done by others. And that's more important than it seems. That it can be very costly in some cases, not all in cases, but in some cases to collect the data, clean the data, process it, and make it available, make it put it in a state that is useful or it's ready for analysis, right, for interpreting it. And all that effort can be lost or can be duplicated if you don't make that accessible to others. And it's a cost of public funds sometimes, it's a cost for researchers, for universities. So the next phase is the data collection, acquisition, and use agreements. I just, in the Harvard side, where we have all these different questions that, again, it's not the point to go over all those questions here, but I just want to emphasize the key points of that phase. And that's important, even though my focus is on data sharing, and it's the focus of the talk, but to think about at the beginning of collecting the data, because sometimes what you need to agree when you collect the data, or the consent, the informed consent that you need to get, for example, in cases that you're getting data from human subjects, that is something that then can limit you in making the data accessible later on. So you need to take that into account in the beginning and think about, even when you are agreeing to use that data, will it be possible then to share it with others? Under certain conditions, obviously, but still that is important. So in this case, when there are two parts of the data collection and acquisition, the way I see it. One is that when we're collecting the data, we want to see if we can provide tools for researchers to facilitate this data collection. And we heard before already a talk related to, if I understood well, about electronic lab notebooks and some of the software, the tools that help you with this data collection, right? So that's important to consider to be part of your data management infrastructure or support. The other part that it's not a software tool, but it's a very important piece, is that when you acquire data from a third party, you often need a data use agreement. So at Harvard, we define that as data use agreements govern access to and treatment of data. So it goes in two ways. They provide, the data are provided by an outside organization to your organization for use in your organization's research, or they're provided by your organization to an outside organization for use in its research. And one of the things that we've done also in order to provide better support for data management at Harvard is to create a data user agreements group that are focused on helping researchers define data use agreements when they want to acquire data from a third party, or they want to make the data available to others. That's not necessary in all cases, right? Because whenever possible, you would want to make the data open without any terms or any conditions or any licensing. But in some cases, it's necessary because either you have sensitive data or proprietary data and you need an agreement. So in those cases, having this support is very helpful, and it's very important for the university, right? And for researchers to be able to track all these data use agreements, having templates about how to create them, and know about them, and understand what are the conditions that they state, because then it's going to be important to know how you're going to be able to share that data at the end of the project. So for the phase of when you're working on your project and you need the storage for your data, and you're still going to be making many changes in the data. You're going to do, in some cases, computation or some analysis, right? Apply some methods, and so there is also a lot of support that you could provide to researchers about that. Some of the ones that I want to point out here is that, the importance of providing secure storage, right? It might be data enclaves, it might be encrypted storage that you have that are compliant with regulations needed to support certain sensitive data. In the US, we have, for example, the HIPAA regulation, right, that applies to health data, to data from patients, and it is important to be compliant when you're working on that data. And if you're going to make it available to others to comply with these HIPAA regulations. For student data, we have FERPA, and it's another regulation that you need to make sure you're compliant, that your storage, and so it's compliant with FERPA. So might be several regulations, or if not if it is not a regulation itself, there might be very good reasons that you want to provide these secure storages. Also, what we're finding more and more across, within Harvard, but many other universities and research organizations, is that they're providing a hybrid model for research computing, right? So it's not anymore that a data center, a self-owned data center can provide everything, or that it might be the most economic way to provide support. It might be a mix of be able to scale when necessary with a cloud. Sometimes it could be a cloud vendor, or maybe an open source cloud, and mix that with the clusters or the HPC that you might have in your, just to use in your university or in your research organization. So the last part of this is that also we've found very useful to provide some consulting and training for choosing the right research tools, technology tools, and the right programs to do the computation, to provide help with optimizing some of that code, provide help with statistical models, with machine learning models. So we have a team within our group, my group, that provides this support across all Harvard, and it's been very well useful to researchers, and they are in high demand. This is not it does require quite a bit of resources, but it is very hard. Well, it becomes harder and harder that one researcher, for example, in biology, will know all the models, all the tools, everything keeps changing every few years, right? What is available? Is there Hadoop or Spark, or are you going to use something else, a new tool that a cloud vendor provides? So having that combination, and not having to assume that the research in one discipline, that whether it's political science, in digital humanities, or in physics, has to know all the tools that exist, is an important part also of supporting data management. So then let's get into the data sharing, which is the part that our group has worked on for the last about 12 years now or so. So first, just the main points of data sharing, and you've probably seen that from Horizon 2020, from the Open Science Cloud groups, that they say make open research data the default, right? And that means as open as possible, as closed as needed. You want to make sure also when you're sharing data that you're complying with the funding organizations and with the journals. So funding organizations not only require the DMP, but some of them require that your data will be accessible to others at the end of the project. And more and more, what they say specifically is that they will be fair. They will follow the FAIR principles, and I'll talk about that. And also we want to make sure that when we're sharing the data, we are rewarding the data authors, the data curators, the data, the people that work on creating that data set, and we can do that through data citation, providing credit. So let's talk a little bit about the FAIR guiding principles. I imagine also that this group probably know about who knows about the FAIR guiding principles here? Okay. Who knew that I was one of the authors? Okay, it's not important, but it is it's a very large group of us that a few years ago, two or 3 years ago, got together, Oxford University, I think was, and started talking about this, the idea about FAIR, to be fair, to give credit. Baron Mons initiated a lot, or came up, I think, with that word. Mark Wilkinson and Michel Dumontier did a lot of that work. But since then, it has been very catchy. And many groups and many federal agencies, many national agencies and so have taken that as their guidance, right? Data need to be fair. And I'll go over what does this mean. So the FAIR principles have the main 4 principles. Data should be findable, accessible, interoperable, and reusable, and 15 sub-principles. And I'm not gonna, you don't need to read all these principles, but I created here sort of a summary of them. I mean, you can read them if you go to the paper and you find every sub-principle well, exactly what we meant by them is not, some of them, there's still a lot of interpretation of how much they need to be supported or not, how difficult it is to support that. But one of the important points about the FAIR principles is that we made it was that it was not all to be data should be findable, accessible, interoperable, reusable by humans, but by machines. That was the main focus, right? And that's an important distinction. I mean, we want humans to use it at the end, but if machines cannot interpret the data, cannot find it, and so we cannot interoperate across systems, across repositories and search engines, and so that's an important aspect. So for findable, it means that data sets must have a globally unique, resolvable, and persistent identifier. So, for example, a digital object identifier, DOI, that is registering data site, would be one of these identifiers, right? Handle uses handle.net, could be another identifier. In fact, DOIs are based on handles, but well, either of them could be used for that. So also the machine-readable descriptions. Well, we need machine-readable descriptions to support a structured search. So that's part of what is important for machines, that if you have metadata that is structured and is understood by a search, then search engine, then that will become findable, right? Accessible means the metadata is accessible beyond the lifetime of the data set, and the clearly defined access and security protocols are needed, because FAIR doesn't mean always open, fully open, right? It might need that you need to restrict some of the data files, some of the data, but still you want to have access to the metadata, to the description of that data set, and this should be findable. And the first point about the metadata is accessible beyond the lifetime, because at some point, maybe there is, in 10, 20 years from now, a data set, the data itself cannot be used anymore for some reason, and that would be an extreme case, but you still would want the catalog, right? You still would want to be able to find that data set existed and what happened to it. So that's part of what accessible means. And this is based on what a library practice, right, for cataloging the objects in a library. So interoperable also is an extensible machine interpretable formats for data and metadata, and it uses fair vocabularies or ontologies. And then finally reusable, so it provides licensing, provenance, and it uses community standards. So all this is a lot of things that you need to support, and you don't want to have to build, or it would be impossible for either every research or research group or even every university to have to build a support for all these FAIR principles and for providing a support for archiving data. And so that's where, in a way, our group comes in and how we think that technology can help you. So with the Dataverse project, an open source platform that enables data sharing and archiving, and it's aligned with FAIR data principles, we provide that support that a university, a research organization would need for sharing research data. So often when we talk about Dataverse, we talked about many things. It's a repository, each Dataverse. Pedro was mentioning earlier how Dataverse can contain multiple Dataverses, and each one is a collection of data sets. So by itself is a repository that is used to find, cite, and publish data. Dataverse is also a platform. It's an open source platform that you can download the software, install it, and use it to build your own data repository for your community. Dataverse is also a community, so we've been over the years, growing contributions to the open source project, building an open source community. And I'll start with talking a little bit about that community. So as of now, there are 35, what we call the Dataverse installations or sites that each one of these dots around the world might support many repositories or many collections of data sets. Some of them might support 20 universities. Some support research from like the Harvard Dataverse support research from all over the world. And some provide support for their own organization or institution. So how this evolve and what, how we've been growing our community, which has been very, very interesting and gratifying. So we launched in 2006. There were 2 Dataverse sites, or installations, one at Harvard and one at the University of North Carolina. And we had about 4 developers in a group, and then we had our first release, right? By 2015, took some years for much of the research community to become more aware or more conscious that sharing data was an important thing. Were reluctant in the beginning, but it started to grow, and we started to have more and more data sets, and we started to build a community. We had in 2015, 14 of these Dataverse installations or sites. We have our first annual Dataverse meeting, which happens in June, and we'll have it again in June 2019. And you see that we growing. We have now these 35 Dataverse sites. There are 74 contributors in GitHub for development of the open source project. Some folks contribute code and actually very extensively features in the software. Some contribute more with testing or helping with some part of user testing or so. We have 30 releases and 17, well, probably this number has changed to 12,000 commits. By now it's probably more because they're committing every day, some code, obviously. So since there was this growth, this year we thought it was important to create a consortium and help new Dataverse installations, new sites, in the process provide some incentive by just having creating a membership to data site for the OIs that could be more economical than if you would do that on your own. And we're still forming this consortium. This is very new, and the site will be launched soon. So let's go into the features. And how am I doing with time? I just want to make sure. that all of you are not starving for lunch. So I'll go, you have until, okay, till 12:30.
You still have 25 minutes.
5 minutes?
25.
Oh, good. Because I was thinking, I don't have time. Okay. So, yeah, let's go over the features. One of the features that I consider very important is data citation. And this, I mean, it's important. It's a simple feature, but it provides incentive for researchers, right? Much of the academia is based on evaluating citations, even though that's not, that doesn't need to be the entire way of evaluating somebody's careers, but there is a lot of, I mean, it's given a lot of importance where you publish, what you publish, and how much have you been cited, right? How much your work has been used. So if we're going to consider data as important as publication, an important output of research, then that means that data citation need to be important too, right? There needs to be considered or valued similarly to citations from publications, from articles. So actually the Joint Declaration data citation principles were based on that. We created that a few years, I think about 3 years ago or so. And they've been endorsed by many organizations. So in the Dataverse, we generate this data citation automatically view. It takes the information about the data authors, right, who created that data set, and it provides attribution to these creators and data providers. It adds a DOI automatically. The citation includes the version of the data set, because it is important also that if you're going to reference a data set, to say which version exactly I used for these conclusions in this article, in this work, right? We also generate a universal numerical fingerprint, what we call it is UNF, which is really a checksum, but a checksum that whenever possible, what we do is that we convert a data file that might be in multiple formats, we convert it into a standard format and then take the checksum of that. So it's a semantic checksum. It doesn't depend on the original format necessarily. So it's the checksum of the values in the data. And that's also part, it's sort of another way of identifying that a data file or a data set. For a data set that contains multiple files, we will add all the checksums of the files in the data set. So another feature that is important is the support for rich metadata. And that's important for searching and for being able to reuse the data, right? So the metadata that is required is the citation metadata. That's the basic metadata that you need to enter when you're creating a data set. And it has the author, the title, a description, and so on. So it's the minimal catalog that you need to describe your data set. Then you can add a lot of more metadata that either follows some standards from your field that are supported in already in Dataverse, or you create your custom metadata. In that case, you can build as many metadata fields as you want that are appropriate for the collection, for your collection, right? We also provide file metadata that is extracted automatically, and in the case of tabular tables or tabular data files, we extract or we provide the variable metadata separated from the files. So some of the standards we support data documentation initiative, the DDI, which is very common in social science, but it also can be used across other disciplines and other domains. The Dublin Core and schema.org. For schema.org is important, and some of you might already know that, how the Google dataset search, the new search that Google launched a few months ago, uses that, the schema.org for the dataset fields of the schema.org. So if a repository embeds the JSON LD, the schema.org fields in its landing page, then this Google dataset search will index the data set, and it will be findable through this new search. So that's one of what you can do is with Dataverse automatically once you deposit and you release a data set, you made it the metadata public, then that is searchable through Google, well, through Google too, but through Google Dataset Search with this structured search. So another feature is versioning, versioning of data sets and files. So a data set can contain many files, and each file might have multiple versions, and that's important because, I mean, you can have also versions of just the entire data set. Just if you change the metadata, you might create a new version, right? So we support minor and major versions, so some of them might be just a small change in the metadata, some might be the entire data file, and you can go and reference, as I said before, any of those versions. The other important feature is the tier access to data. So I said that data should be as open as possible, or that's a recommended, what is recommended by the community, but also as restricted as needed. And in some cases, you do need to have some files restricted. They might need to be restricted only for a certain time until they can be used because there is an embargo, or you need to restrict it indefinitely because they contain sensitive data, or because can only be used under some conditions or licensing that you need to agree to. So that's why we provide this flexibility, because it is important to be able to support, to not scare researchers when we say you have to make your data accessible. Well, in some cases, you can do that, but at least you can make the metadata accessible. Maybe there will be some versions of your data files that can be accessible and open, and the rest could be accessed if a user requests access and you grant them access because they apply to the conditions, or they agree to the data use agreement. So in some cases they might not be able to have access, but at least they know that that data exists, and if needed, somebody might need to access it for reviewing and verification, right? So there are also a lot of other ways to access the files we mentioned before, the guest book. So in some cases, you might not need to have the data fully restricted, but you want users to register, and you want to track some information about each user that downloaded your data, so you can set up that for your data set. Also, just let me point out that by default, the Dataverse provides, gives it a CC0 waiver to your data set and makes it open, but you can then restrict it or change the licensing to something else. But the most standard, Creative Commons license, I would say, for data, for open data should be this CC0. So another feature that distinguishes Dataverse from other repositories is that how we process some of the files. So at the time of ingest, when they get uploaded, automatically, depending on the file format, it might, if it understands that format, for example, here in the case of a CSV file, an Excel file, an SPSS file, an R data frame, or so, we'll try to extract the variable metadata, so that if that file is a table and every column is a variable, it will get all the information about each variable. And that becomes important because then later we can use some tools, exploration tools or analysis tools, that they don't have access to the data first, but they have access to what is each variable. And then they've done, they processed the summary statistics, they've done calculations about the distribution of each variable and so on. So you can have a good review of that data set even before you download it, right? It gives you a summary of what that data set contains and what is each variable and how this variable is distributed. We do that for other types of files, but in a different way. This is one of the cases that it needs to be custom for each format, right? That, for example, if it's FITS files that are commonly used in astronomy, we extract some of the metadata that is in the header of the file. And that can provide already, can be very useful to researchers that instead of entering and duplicating all this information that was already captured at the time of the observation, because the instrument, the telescope that they, or the software that they created that file with, had all that information about that particular observation, so that's already automatically extracted from the file, and it becomes part of the metadata of that file. Another feature of Dataverse is that you can customize your own Dataverse. So when you have a Dataverse installation or repository, you can create multiple Dataverses, and each one can be either for a researcher, a department, a school or so, and each one of those could be customized with some settings and with branding. And the last feature, not the last slide yet, but the last feature, is the API. So it's very important for any data system, any software that wants to interoperate with other tools to provide an application programming interface. And we have a very extensive API. Some follow standards like the SWORD standard for depositing digital objects to a repository, and some of the API is native to our application. But that has allowed many tools to integrate with Dataverse, and there's more tools than these ones, but here are some examples: the Open Science Framework, the Open Journal System, the RSpace, which is an electronic lab notebook, World Map, Dropbox, ORCID, so all those different systems can integrate with Dataverse through the API. And of course, we could add more and more. So what type of data are supported in Dataverse, and what kind of Dataverses we have? So we have some Dataverses for journals. So we work at Harvard, the Harvard Dataverse repository, we work with 80 journals. We have Dataverses for individual researchers, for research communities, and some installations of Dataverses that support multiple institutions. So let's talk a little bit about the journals. So many journals, and increasingly more and more, they have defined some data policies that either require or strongly encourage to submit the data and code at the time of submission of an article. We did a study to review in social science for the top journals in some fields what policies did they have. So here, since you probably cannot read that, the first one is an anthropology, the second is economics, next history, political science, psychology, and sociology. And those are based on the 50 top journals based on the rating from I think it's from the Web of Science or so, the rating that they provide. And we review the data policies, and for most of those disciplines, if you add up, first, red is that there is no policy, blue is that there is a data policy that encourages or strongly recommends to deposit data in a repository, and green is a data policy that requires. You cannot submit the article if you don't deposit the data in a repository. There might be some exceptions, but very few exceptions. So if you combine the blue and the green, 5 of these disciplines have 50% of the top journals either require or encourage to submit the data at the time of submission of the article. So that I don't have data for the biomedical journals, but it's also for biology and biomedical, there are many of them are starting to require sharing the data. So here's an example for a political science journal that not only required to submit the data and the code, but they have a third party that reviews the data and the code and makes sure that all the results in the paper they are reproducible, at least in terms of computational reproducibility, so that you could run the data and code and get the results published in the paper. Here's an example of a Dataverse for a researcher. So your own researcher can create its own collection and has as many data sets as he or she wants. Another example for a research community that have an installation of Dataverse. This one is not in production yet, but it will be in a couple of months. It will be another of these dots. It's used for the structural biology community. So in this case, it's going to be hosted in the medical school. Well, it's already hosted in the medical school, but the Harvard Medical School. But it's used by organizations all around the world that are gathering, or they have a structural biology data, diffraction data, so that is basically the primary data from protein data structures, right, from protein data bank. So another example that is probably relevant to use, that you can have a Dataverse installation or repository that supports multiple universities. Here's a Texas data repository, which Texas is almost like a different country in the US. So if you can compare it, the size of Portugal or bigger, I think bigger, it's the size of Spain. So they have 24 universities, and they have a consortium, and they support one hosting. They provide one group that will support across all those universities. I think every university then have a subgroup that will help their researchers, but they have organized and coordinated that to provide one solution. Also, our friends in the Netherlands that we've been working with them for a very long time, they have a Dataverse installation there, a repository that supports I believe it's 13 institutions in the Netherlands. And it's hosted at DANS, at the Dutch Archive, National Archive. And the Harvard Dataverse is one of the examples of data repositories that supports data from researchers around the world, from many collaborators within Harvard and outside Harvard. And since we've been running it for a longer time than others, we have gathered a lot of data. There's been a lot of deposits. So there are 30,000 data sets. Each one of them might have few files to 100, some of them might have 100 files. I think there is a total of about 250,000 files. And those are the ones that are deposited in Dataverse, in the Harvard Dataverse, but then we also harvest, federate with other Dataverse repositories. So there's a total of 80,000 data sets that you can find in our repository. But when you find some that have been harvested from another repository, you would go and download them or access the data in the original place, in the original source. But because we use the APIs and OAI-PMH protocol to be able to harvest metadata like a Dublin Core or DDI or so, standard metadata, then we can find all the data sets that are in other repositories. So we've had in the last years an average of 200, well, at least in 2018, an average of 250 data sets per month. This is, to me, it's quite impressive given that when we started, it was hard to convince researchers to share the data. Now it just happens, right? They just come and deposit the data because either maybe the journal has required it, or maybe because they realize that it's the right thing to do, or for several reasons, but there is some starting to be a cultural change on that. And also they have the flexibility to restrict what they need to restrict, right? So there have been 5 million downloads of other data files. So the data are used, which is what we want, right? We want reusability. And that's 150,000 downloads per month. So I'll finish with the projects that we're working on. Those are still not in production. They're not all of them features that already exist in the Harvard Dataverse, but we are testing them and implementing them and working on that. So first, for large data, some of this it is already in some of the production features, and the structural biology group is already using some of these features. So, and that was a contribution from this group, from the structural biology grid, that they needed to have other types of uploads that were different than an HTTP upload, right? When you're talking about megabytes or gigabytes data files, it's easy to say, well, just upload it through HTTP, just through our web application and a browser, and just add the data and the metadata, so and so. But when you start having much larger files, you want other methods, other protocols for uploading the data. So in this case, they implemented rsync in Dataverse so that you could upload the data through through this method, and they made that available for other Dataverse repositories. We also considering, for example, to integrate with Grid FTP and from the Globus transfer. We've been talking with them about that, but that's part of the process, the ongoing project for supporting large data sets. Also, some of the other important things about large data is that often you need it to be local. You cannot download it in your own computer to work on it, or you wouldn't want to do that. And in this case, then we were testing this with the Massachusetts Open Cloud to be able to have when you find the data set, you have a button to say compute or access the data set in the cloud, and then if you have, given that you're granted permissions to access that data set, you can use it with all the tools that the cloud provides, and so. So that's this work in process, and that also helps for, part of that work also is extended by these remote secure agents or remote storage agents, meaning that there are some groups that they might provide their own storage, and they have a contract with the Dataverse, with the repository to say, here's the metadata for my data set, the data are stored here, and you can access the data, but it's remotely stored and not stored in the Dataverse repository file system also. So for sensitive data, I will talk more this afternoon, right? This afternoon about this project on data tags and differential privacy. So here just to let you know that we're working on that, and I'll describe that later on today. We're also working on a project to integrate with reproducibility tools, and that that helps the journals. And it's one of the groups that it helps, but it's also just helpful for research institutions, and so to know that the data sets that are deposited in Dataverse could be easily enable or make it facilitate how to reproduce the results. If a data set might contain the data and the code, and that code might be an R script or a Python script or some other code that was used in the analysis. And the integration with corrosion means that, how many of you know what corrosion is? So it's a relatively new, about a year ago, web application that allows you, it's similar in a way that Jupyter Notebooks, that allows you to just take the data and the code and execute it online. So it provides the containers to execute that in the right environment and with all the dependencies, the libraries that you need. So it just makes it easy that instead of you setting up that in your own environment and have to figure all those things out, you can just drop the data and code there, and it does that for you. So we're integrating with them, and we're actually just just agreed on a collaboration with Nature journals to be able to provide the Dataverse and the Code Ocean as a way to pilot a reproducibility project with Nature publications, some of the manuscripts, not all of them, but they'll use a few of them to make sure that they reproduce, computationally reproduce. Then another one of these type of reproducibility tools is one that we're building with in collaboration with Margot Seltzer, computer scientist, who's at Harvard, just went to Canada, to British Columbia this year, but we're still working with her to create this open source solution we call encapsulated that creates a time capsule, a container that has the data, the code, and the provenance file that can connect or has all the information, the metadata to how that data and code connects and how to execute it and all the parameters needed. So this is in development. It's a research project, but it's interesting. And then we work with the University of North Carolina with this Core 2 tool for also verifying results from publications and providing sort of management of peer review of data and code. Like similarly to when you have peer review of a manuscript. So the last project that we're working on, and all of those projects we got funding from different sources, so we're very thankful about that. In this case, it's from the Institute of Museum and Library Services, the AMLS. And it's a small project, but I'm very interested in that because we hope it will help us to understand better how to build open source projects in a way that is successful, what works and what doesn't work, and evaluate in a quantitative way what are the criteria that you should apply to an open source project. So I call that a health index for open source projects. So finally, I'll finish with the top 5 reasons. Pedro went ahead with the 10 reasons, so this he won. But just as a summary, I think it could be useful for Portugal, for your institutions and your infrastructures to provide a Dataverse repository to help you with data management, because, well, it will help you to be compliant with some of the requirements that are coming with Horizon 2020. It will help you to be compliant with journals. It will have to give credit, well-deserved credit, the data authors, the researchers should have for sharing the data. If you have the repository here, you have you're providing an archive and you have full control of where the data is, how do you integrate it with your own tools, how you create storages that are more sensitive or less sensitive and they are compliant with your requirements. So you have full control of that, but still without having to develop the entire system on your own. And of course, the fact that it's open source, you could add new features or customize what is needed. And in general, I think that can improve collaboration with the rest of the world and improve science. The end is science and humanities and all research knowledge. So that at the end that's what we want here, right? So obrigada. Thank you.
Thank you very much, Mercè, for this excellent presentation. Well, we're a bit late, but I think that we should allow for questions. So, João.
Hi, João Mendes Moreira, FCT. Thank you for your excellent presentation. I don't know if this is a fair question, but I would like for you to comment on, and neutral, but how do you benchmark Dataverse with other solutions?
Yeah, it is a good question. I don't know if I'll remember Oh yeah, I should talk. Okay, I don't know if I'll remember all the different criteria and different features, but we do have openly. We've created a document, a table that we compare with fixtures, or with Dryad, with a different CCAN, with different solutions, and we tried. I mean, you could say that just because we built it, it might be biased, and so we really open it to all of those groups to say, tell us what is wrong, what is missing. So there is a whole set of features, and so if you go from Dataverse, I mean, I can share the information, but from our website you can. There is a blog that talks about these differences and compares the features. I mean, I think that some of the different. So there are repositories like Fixture or so that in a way they have a lot of useful features, right? And they compare in some ways with the way they provide data citation and persistent identifiers and some metadata and so. But it's not an open. I mean, even if they might be open source, it's not a software that you can use and install in your institution and just customize it as you need. And so that's one of the differences. There is CCAN and others that you could do that. But what I would say is that in terms of for example, support for metadata and flexibility in metadata is more extensive in Dataverse than the other solutions. Also, some of the features that I pointed out about the way we extract metadata from some files, right? Some features specific to some data files is something that I haven't seen in the other repositories. So I'm not a seller, maybe, so I might not be selling it well, but I think that maybe Pedro has a whole list of other things that you compared. The tier access, okay.
You compare with others.
Yeah.
For example, you compare different access modes that we have in others versus comparing with second.
Right. I mean, to me, at the end, the most important part, besides all these features, because things evolve, right? Features you can be added, is that there is this open source community that is really contributing and making that project sustainable long term. That it allows to grow, like all these projects that are research projects now with sensitive data, with provenance and reproducibility, and so are things that you can do when you have a community that can contribute to code to the project. So that despite, I mean, in addition to the features that are already there that I think are very valuable for data and data management, the fact that can be extended and you can contribute to it. Questions?
I have, Christina.
Thank you, Mercè. You have an amazing amount of work in this platform. And my question is about, well, we know that these software systems tend to, well, wear very quickly. Just new things appear. And I was wondering, what provision do you have for migrating, for keeping up with all the intellectual work that people put into metadata, organizing data, etc. Because that's one thing that makes people confident in using the systems, is knowing that they can get out.
Yeah, so there are a few things. Not everything is as ready to use as we would want it yet, but I know we've got from the community also requests about that. So for one thing, all the data and the metadata, are stored in files separate from the relational database where there is all the application information, right? So we extract every day. Well, we export all the metadata into different formats, so connected with the data file. So you could take all these, and I mean all that information, all the valuable part of the data sets could be exported very easily. In terms of maintaining all the structure, a lot of the information around the organization of Dataverses and so on. So you can get a lot of that through the APIs. It's not in an easy way. I mean, we've been adding some tools to make it easy to migrate, but it depends to what you would migrate it to. Might be easier than not. But basically, all the actual contents, data contents, can be exported very easily. And we made a big point of, for example, for some of the data files, not only is exported easily, but also we convert it into multiple formats, so that it's not only the original format that might be proprietary, but it has also preservation formats. So it's one way of doing that. Within Harvard Dataverse, what we have also is we're part of an organization called Data Pass, and we with other universities and other repositories, so that if our we have a sort of a contract that if one of any of these repositories would not be sustainable anymore, would have to disappear, one of the other, I think there are 8, would take the data. So it's sort of a succession plan, which is important when you have an archive. We also archive the data, I mean, in 3 different locations. And that's easily set up when you set up your Dataverse.
Thank you.
Thank you very much for this presentation.
Thank you.
Mercè.
Have a good lunch.